So
Okay.
basically, through an understanding of limits, you can understand derivatives, you can understand integrals, everything. So basically, if you know what limits are, then continuity, differentiability, differentiability, derivatives, integrals, everything has the definition of all of these things is based on limits. So let's discuss this. Questions on this chapter will be more or less like find a particular limit, right?
Yeah.
So what we mean by this idea is that if there is a function, if there is a function y is equal to fx, which is something, so let's say x square minus 4 by x minus 2, let's say, right?
Yeah.
Now, what we want to understand is the behavior of the function as say x becomes close to some particular value, as x becomes close to some value, let's say a. So what is the value of the function, or where does the function tend to, right? So limit of x tends to a, f of x, is basically the non-technical meaning of this is to what value does the function become close to if
Okay.
you bring x close to it, right?
Yeah.
So we don't know, but we will have to find this out, right? This is a non-technical definition. That means uh, the rigorous definition of this would be involving uh, both left hand limits and right hand limits. So we will draw a graph. We'll say this is my x-axis, and let's say this is my function, and this is my point A, near which we want to find out the limit, right? So if you bring your x, this is x-axis. So if you bring your x close to A, right, from here. So
Yeah.
when x was here, the value of the function was this value, f of x, right? This was
Yeah.
the value. So when x becomes closer and closer to A, you will see that the values are increasing slightly, right?
Yes.
And when it becomes close to A, it will have something close to this value, right? So from the other side also, if you bring it lower, then also the values are approaching the same value, right? This
Yes.
is the f of A, right?
Yeah.
So, so if from both sides the function is going to approach the same value, then we will say that the limit exists. So, limit exists if function approaches same value, approaches the same value as x tends to A from both left and right hand side, left and right sides. So we need to understand the meaning of this left and right sides. Basically, you can have a x is less than a and becoming bigger, or x is greater than the a and becoming smaller, right?
Right.
And what is the value of the function approaching? So that is what is the limit. But the limit is said to exist only if both the tendencies are matching. Like it should not be like this. For example, the function should not be like this, where it is defined till here like this, and then it is defined like this, right?
Okay.
This is my function. This is called a piecewise defined function, right? Piecewise defined function. Why is it piecewise? Because for one portion of the graph, right,
Yeah, it is defined in a different way in the
and
other.
the other it is defined in a different way. So what happens here is that if you come from the left side towards A, your values approach this value, and then you come from the right side towards A, right,
Which is another value.
it approaches another value, and this is different from each other. Therefore, no limit exists at
Yeah.
A, at x is equal to A. So this is the basic meaning. So what we look at is the classical definition of the limit also. So this is a definition that is given in terms of epsilon and delta. These are two numbers. two numbers. So we say that limit x tends to a fx exists and is equal to capital L and is equal to capital L if for every delta such epsilon such that x minus a mod is less than epsilon implies that fx minus L mod is less than delta. So what this means is you need to understand, if for every epsilon you can pick a delta, or in the reverse manner think of fx values are going to be something, right?
Yeah.
Now you want it to be very close to L, no? You want it to be close to L as x gets close to a,
Yeah.
right? Then only it will be a limit, right?
Yes.
So what this really means is you can pick a delta. This delta is a difference in values of fx and L, right?
Yeah.
Basically, on the y-axis, if you have L somewhere here, right? And
Yeah.
fx values will be plotted somewhere on this axis, right?
Yes.
So if someone says that my fx value should be less than 1% different from L, right? Different from L. So that means basically my fx can be in the range of 1.01 L to 0.99 L, right? Correct.
Yeah.
So if I pick my delta, this delta such that the difference between fx and L is less than some 0.01 or something, right?
Yeah.
Then I will be able to find an epsilon on the x-axis where I need to place my x's. You understand?
Yeah. So it will be like if it's 1% different there, there'll be like some difference in
Some
the.
difference in x, which will, if you get it close to a by that much amount, which is this number, right?
Yeah. It will be close to
Then
L.
it will be close to L by that 1% difference, right? So
Yeah.
the whole idea is that no matter how close to the L you want to make it, right? Like if I said that my function value should be limit value, let's say, is 2, and my function value should be close to 2 by a factor of, by a difference of 0.00001, right? So
Yeah.
you can go from 1.9999 to 0.0001, right? So
Yeah.
even if I pick such a small interval of difference for fx and L, then also I should be able to find a corresponding range of x close to a, right?
Yes.
Such that that is going to happen, right?
Right.
So by this method, you are what you are really saying is that no matter how close you want to get to the L value, right? You will be able to find an interval near a which is going to let you do that, right?
Right. Got it.
But otherwise, for functions where the limit does not exist, what happens is you are not able to find such an interval. You are unable to find two numbers which will satisfy this property, right? Because it might be jumping or oscillating. The function value might be jumping across that limit, right?
Yeah.
Complicated functions where this doesn't happen. Like you cannot get forever closer and closer to fx value by bringing your x values closer and closer to a, right? So
Right.
this is the more technical definition. Mostly this definition is not going to be used in at least the 11th and 12th grade, but as soon as you go to higher levels, this is the definition that you will work with. For now, understand that for function to have a limit, you have to have x tends to a minus of fx is equal to limit of x tends to a plus of fx, and both values should be equal to the common L. Then only you will say that limit
Limit.
x tends to a fx is equal to L, right?
Yeah.
Now, by this a minus and all, what I mean is come from below to the A, right? And what I mean by A plus is come from above near A, right? So this limit can also be written as, if x tends to A minus, you can also call it like this: limit h tends to 0, f of A minus h. Okay. So notice that here, if h is tending to 0, h is always positive now, but it could have been 0.1, 0.01 and stuff, right? And
Yeah.
you are getting closer and closer to f of x, right? But f of A, but from below you are getting closer, right?
Yes.
And this should also be equal to limit h tends to 0, f of A plus h, right?
Right.
This is saying the same thing as saying this. You should understand this point clearly. Why here h you are using is positive. Here A minus, it was difficult to write that, right? A
Yes.
minus and A plus is not a proper notation. It is just to understand. This is easy enough to understand, where you're saying in this one, you're approaching from this side. So F value should be slightly lesser than H, and here slightly above A, right?
Yeah.
So you have to basically check whether this limit is equal or not. And if these two limits are equal, then the function has a limit, and the value of that limit is equal to the value of these two limits, right?
Right.
Otherwise, it will not have a limit. So now let's look at, for example, limit x tends to 2 of the first function that I had written, this one, right? So if you notice that the function is not really defined at 2, right? Fx is not defined at 2. So sometimes it is going to happen like this, that the function is not defined at that particular value, but still you can get very close to it, right?
Yes.
So this is the 2, and the function graph is something like this. Y is equal to x plus 2. Notice why y is equal to x plus 2, because when you cancel it off, it becomes x plus 2, right?
Yeah.
So there is a gap here. I have put a circle here because at 2 it is not defined, right?
Yes.
If you put 2, there's denominator is 0, right?
Yeah.
So however, even though it is not defined at 2, you can still get close to 2, right? As
Yeah.
you get closer and as long as you're not exactly equal to 2, you can still get infinitely close to 2, right?
Yes.
So the tendency when you go to 1.999, suppose, right, then it is going to be close to 3.999, right,
Yes.
value. And at 2 it would have been 4, but that is not defined, so it will never really become 4, but it will be very close to 4, right?
Yes.
It will go as close to 4 as you want it to go. Like no matter what interval I choose, I can get as close to 4 as possible, right? By choosing a corresponding interval on the x-axis, right?
Got it.
So both sides, you are seeing that it is becoming closer and closer to 4. So the limit of this will be 4, even though the function is not defined at 2, right? So
Yeah.
it is okay for a function to have a limit at a point where it is not really defined, because limit actually means the tendency in the neighborhood of that point, not the actual point. Okay.
Got it.
So here the limit will be called 4 because from both sides you are approaching the same value of 4, right?
Yes.
So we will look at how to get some of these limits and all. Let's look at some graphs and all, and see whether we can understand how to calculate some limits. So for example, I am going to draw some graphs, and we are going to decide whether the limit exists or not. Okay, so this is 0, this is -1, 1 2 3 4 on top, 1 2 3 4 and so on, and here 1 2 3 4 5 6, 1 2 3 4 5 6, and the graph is like there is a blank here and it goes up till here, and then there is a value like this blank here, and it goes up like this, and there's a point here. Then after that, it's going to be a blank here and goes up like this, blank here, and after that it goes down, and after 6 it starts rising up again. After 6 it rises up from this point again like this, right? So this is my function right now. Okay, this is the graph of a function. Graph is given. Okay, so what we want to understand is what happens due to this. Whenever there is a circle, that means it is not there, the value is not there, it is some other point, right? This point is the value of the function, right?
Yeah.
So what I want to find out here in this is limit of x tends to 0 minus of fx. First of all, 0 minus, so 0 minus of fx means it should be approaching 0 from the left hand side, right?
Yes.
However, the graph is not even giving us any graph for that, right?
Yeah.
So there's no graph for it, so function does not even exist there, right?
Yeah.
So if function does not exist, obviously limit does not exist, right?
Yes.
Okay, so limit does not exist because we don't know what the behavior is at that point, right? Then limit of x tends to 0 plus of fx, right? Now this leads to an important idea, that notice that one side the function does not exist, right? And
Yeah.
one side it exists, correct?
Yes.
So at the end point of an interval, right? At the end point of an interval, and suppose you have the definition of the function like this, right? So at the end points, only one side limit will be there, no?
Yeah.
There is no other limit from this side here, right? So at the end points, the function will have only one-sided limit, right? It will not have two-sided limit, right?
Yes.
So at this point, you can say that 0 plus limit definitely exists and it is going to be close to -1, right?
Yeah.
When it was 0 plus, it was close to -1. So that will be the limit. On the other hand, 0 minus fx is not existing, right?
Yeah.
So that is the understanding here. Then let's go to limit of x tends to 1 minus of fx. Limit of x tends to 1 minus of fx, right? So limit of x tends to 1 minus is going to be only near 1 from behind, right?
Yeah.
So my diagram is a little wrong. This 1 should have been here, okay? That is
Okay.
what is meant in the question. So 1 should have been here. So 1 minus of fx, it is approaching 1, no?
Yeah.
Correct. And limit of x tends to 1 plus of fx is approaching 2, right? From this side.
Yeah.
So we will say that at 1, the limit does not exist, right?
Yeah.
Because the left hand side limit is not equal to the right hand side limit, right?
Yeah.
Okay. Then what is it at 3? At 3, this side limit is becoming 2, right?
And the other side is becoming 3.
3. So it is also not going to exist, right?
Yeah.
At this point, however, 5, right? Both sides limit are approaching the same value of 4, right?
Yeah.
So even if it is not defined here, limit still exists. Limit x tends to 5, fx is equal to 4, because from both sides you're going to 4 only, right?
Yeah.
At 6, this graph is going very down and almost vertically down, right? So
Yeah.
at 6, limit x tends to 6 minus fx is actually minus infinity, right?
Yeah.
This infinity is not a real number, but it's just, this suggests that it becomes very low, right?
Yeah.
And limit x tends to 6 plus fx is equal to 0, right? Because it starts from right here.
Yeah.
So obviously at 6, the limit does not exist, right? Because 6 minus and 6 plus is not the same, correct?
Yeah.
Okay, so this is the understanding that you need to have. After this point, there will be some rules for finding out the limits, and it's about learning those techniques for finding different types of limits. So that we will look at now. So there are these sum, difference, product, coefficient, product and quotient rules. Uh, This all this you have seen in your class, no?
Yes.
So basically, limit of x tends to a of fx plus gx is simply going to be L1 plus L2, where limit of x tends to a fx is L1 and limit of x tends to a gx is L2, right?
Yeah.
So the limit value will be the sum of the limiting values of each of the functions. Same goes for subtraction, right?
Yeah.
Is also going to be the same thing, limit x tends to a, and multiplication and division also is going to be the same thing. But division, there is a caveat. The caveat is that L2 should not be 0, right?
Yeah.
L2 should not be 0. If L2 is 0, then there is no limit for this, right?
Yes.
And this is L1 into L2, right? So this helps us evaluate various limits. So you also have a constant multiple rule. So if you have a k times fx, the limit of that should be k times L, right?
Yeah.
And suppose you have fx to the power m by n, the limit should be L to the power m by n, as long as this is defined, right?
Yeah.
This should be defined. It should not be something like L to the power 0 by 0. That doesn't make any sense,
And yeah.
right? So that's fine. uh, okay, then one more thing, one more rule is for composite functions. So limit of x tends to a f of g of x, right,
Yeah.
will be the same as f of limit of x tends to a g of x, right,
Right.
which will be equal to f of m, where m is equal to limit of x tends to a g of x, right?
Yes.
But this rule is only true. This rule, this is an assumption, no, that you can take the limit inside, right?
Yes.
And this rule is only true if f is continuous at m, at the value m. So what we don't know right now is what is the meaning of continuity. So we will cover this later. When we discuss continuity, then we'll know what this means, right?
Right.
So for now, just remember that you can do this in some special cases. And what is the case? That f has to be continuous at m. Okay. So right now, because you have already studied continuity, you probably know what continuity is, right?
Right. I do.
So what is continuity?
The graph is not broken at the point it's
So
continuous.
basically, f is continuous at m means limit of x tends to m, f of x is equal to f of m,
Yeah.
right?
Yeah.
So this, first of all, this limit should exist, and the value of that limit should be equal to the value of the function.
Yeah.
So that is the meaning of continuity. So if it is continuous at m, then this, you can do this. You can take this limit thing inside and take the limit of this and find out f of m. Okay.
Yes.
So what we look at is some questions. Let's look at some questions now. Once again, just hold on for a moment. Hello.
Hello.
Yeah. Okay, so let's look at some examples, and from there we can just try to figure out what is going on. So, okay, the first question is limit of x tends to 2, 1 by x minus 2 minus 2 into 2x minus 3 by x cube minus 3x square plus 2x. This is the first one. Second one is limit of x tends to 2, 2 power x plus 2 power 3 minus x minus 6 by 2 power minus x by 2 plus minus 2 power 1 minus x. This is the second one. Let's see these two and try to figure out how to get these limiting values. The first one, you should try to factor x.
Yeah.
This part is easily factorizable. Right?
Yeah.
So take the 1 by x minus 2 common and it becomes 1 minus 4x minus 6 by x into x minus 1, right?
Yes.
So that becomes x square minus x minus 4x plus 6 by x into x minus 1, and denominator there's an x minus 2 also. So that becomes x square minus 5x plus 6 by x, x minus 1, x minus 2. And again, top can be factorized as x minus 2, x minus 3 by x, x minus 1, x minus 2. And x minus 2 can be cancelled. So the
Yeah.
whole point was to be able to cancel this, because right now you cannot put the value, right?
Yeah.
So once we are able to cancel this, we get x minus 3 by x into x minus 1. And in this one, it is okay to put the values of x is equal to 2, right?
Yeah.
So it will be minus 1 by 2 into 1. So minus half, right?
Yeah.
So that is the first one. Second one you can try. First thing you should do is check whether it is undefined at by just putting the values, is it working out or not? But it will not work out mostly because denominator will become 0, I think. Yeah.
At 0.
Yeah. So you will have to think of something. This is what it is looking like, no?
Yeah.
Okay. So let's just do common denominator and stuff. The 2 power x, this becomes 2 power 2x plus 8 minus 6 into 2 power x. and this becomes 2 power x. This becomes 2 power x by 2 minus 2, right?
Yes.
So 2 power x and all you can cancel, and this is the thing. So now you have on top, you have 2 power 2x minus 6 into 2 power x plus 8 divided by 2 power x by 2 minus 2. Okay.
Okay.
What will you do now? It is still not working out because this is becoming 0 still. So can you notice something about the numerator? It is easily factorizable. Middle term factor, right?
Yeah.
So what are the factors? 2 power x minus 2 and 2 power x minus 4, right?
Yes.
By 2 power x by 2 minus 2, right?
So, yeah.
Now this is a square minus b square, where this is a minus b. See?
Yeah. It will get cancelled.
So it will get cancelled and it will become 2 power x by 2 plus 2 on top, right?
Yeah.
And now there is no problem. You can put the value of 2. It becomes 4 minus 2. 2 into 2, 1 plus 2. So 4, right?
Yeah.
8 is the limit. So the whole idea is you might not get immediately the limit, but you have to do some manipulations and some algebra and some clever tricks to be able to find the value of the function, even though on first glance it looks like it might not be defined there, right?
Got it.
So let's do one standard limit, which is limit x tends to a, x power n minus a power n by x minus a. Now here too, you cannot directly put it, so you have to think of some way to do this, but you can actually divide it because x minus a is a factor of this, right?
Yeah.
So what happens when you divide this? You will be able to say that x minus a multiplied by something, this is, right?
Yes.
This factor you should know. I mean, you can check it out by doing x cube minus a cube by x minus a. What you will get is x square plus ax plus a square, right?
Yes.
So this will become x power n minus 1 plus x power n minus 2a plus x power n minus 3a square plus so on till x power x a n minus 2 plus a power n minus 1. What is happening here is that you are increasing each, you are adding all the terms with such that they have degree n minus 1 here. See here, x power n minus 2 and a power 1, right? It adds up to degree n minus 1, right?
Okay, so you're reducing x and increasing a.
So it will vary from all, basically you're listing out all terms which can possibly have degree n minus 1. And you can check it. See here, it was 3, 3 and 1, 1. So when you divide, it should be quadratic. And you will write all the terms with 2 degree, right?
Yeah.
If you do, suppose x power 4 minus a power 4 by x minus a, you can do it in two ways. You can do it from the what is predicted from this, or you can do it by hand also actually. So you can say that this is x square minus a square by x minus a into x square plus a square, right? So
Yeah.
technically this is x plus a into x square plus a square. So if you do the calculations manually, you will get x cube plus a square x plus a x square plus a cube, right?
Yeah.
See, these are all the possible degree 3 terms, right?
Yes.
So that is what this should have been. This should have been x cube plus a x square plus a square x plus a cube. That is what this formula will give me, right?
Yeah.
So this is a standard factorization. What is the denominator of x power n minus a power n by x minus a? This will be this. So once you do that, By long division also you could have done this, right? Like this is just simply division, okay, of
Yeah.
two polynomials. So you will get a series like x power n minus 1 plus x power n minus 2a plus x power n minus 3a square and so on till x a power n minus 2 plus a power n minus 1 and limit of x tends to a, right?
Yeah.
And when you put the values it becomes a power n minus 1 plus a power n minus 1 plus a power n minus 1, right?
Yes.
And powers of a are going from a power 0 to a power n minus 1, so there are actually n terms, right?
Yeah.
So it will be simply n into a power n minus 1, right? This limit,
Mm.
you understand, because each term becomes a power n minus 1, right? And there are n terms. Are you
Right.
understanding?
Right.
So actually there will be later when we do more limits, what we'll see is there is a rule called L'Hopital's rule, right?
Differentiating numerator and denominator.
So there is a rule that says if you get a limit which is of the form 0 by 0 or infinity by infinity, right?
Yeah.
If you ever get this type of limit, what you can do is fx by gx limit of x tends to a will be the same as limit of x tends to a f dash x by g dash x. And you can keep continuing this process as long as you still keep getting these terms.
Yeah.
If in the second step only it became 0 by 1, then the answer is 0. However, if in the second step after differentiating it was still 0 by 0, you have to differentiate it, you can differentiate it again. And maybe at some stage it becomes something which is not 0 by 0, right?
Yeah.
So you can keep repeating this process so long as this form is going to keep coming, okay? And whatever is the final answer when the form goes away, that will be the answer. So sometimes, many times L'Hopital's rule works. Sometimes it doesn't work, however. So this should not be like the only trick in your hand, in your arsenal, right? It should not be like always I'm doing L'Hopital, because what happens is the questions are designed in such a way that differentiating might be super painful.
Yeah.
Okay. Like it would be really annoying to differentiate. So it is good to think of other options also. At the end, if nothing is working, maybe L'Hopital will work, right? And be careful, because we will see examples where L'Hopital will not work also sometimes. Because what happens is it could keep becoming some other form which is still 0 by 0, and when you differentiate again it comes back to the same form which is still 0 by 0.
Okay.
So there are cases like that. I will show you examples like that. But for now, this one is super easy if you do L'Hopital, right? Right now it is 0 by 0, so you can apply L'Hopital. It can only be applied in these two cases, okay? So you can apply it. So differentiate it with respect to x. Top part becomes n x n minus 1. Bottom becomes 1, right?
Yeah.
And limit of this as x tends to a is not in 0 by 0 form, right?
Yeah.
And that is simply n a n minus 1. So that is the answer. Okay, so it is very useful sometimes because it is much faster. However, it is not the only thing that you should know. You should be able to do it in a normal way also. Okay,
Okay.
then let's look at some more questions. Basically this chapter now will be a collection of different questions and handling those by different techniques. So we will have to do a lot of questions here, and then by the end we'll be fairly confident of being able to calculate limits. Okay,
Okay.
so fourth one is limit x tends to 1, x power p plus 1 minus p plus 1 into x, p plus 1 into x plus p divided by x minus 1 whole square. So it is 0 by 0 form, you can see, right?
Yeah.
So maybe L'Hopital you can try. Numerator, you can try and differentiate. It becomes p plus 1 x power p minus p plus 1, right?
Yes.
And denominator becomes 2 times x minus 1, right?
Yeah.
And here p plus 1 you can take common, p plus 1 by 2, it is just simply x power p minus 1 by x minus 1, right?
Yes.
And this is still 0 by 0, x tends to 1, right?
Yeah.
But just the previous question, you know how to do this. This is still 0 by 0, you can differentiate it once more, right?
Yeah. But it's in the form of x to the power n. So
Earlier also it was form of x power n only. Is there a problem?
no.
Earlier also it was in the form of that only, no, x power something.
Yeah. Mhm.
So the limit becomes p into p plus 1 by 2, right? Because this limit becomes 1, becomes p now, right?
Yeah.
So basically after 2 times doing L'Hopital, you are getting rid of the 0 by 0 form. So what happens at the end of that 0 by 0 form after we got rid of it, then that is the limiting value of that. You could have done this question without L'Hopital also, by the way. That would have involved taking this x common and stuff, trying to figure out a way. So x common here, it becomes x power p minus p plus 1, right?
Yeah.
Maybe first split it a little bit. So I will do x power p plus 1 minus px minus x plus p, right?
Yeah.
So let's do x common here, x power p minus 1 minus x minus 1, and this is minus x plus 1, so I have to do plus p minus 1, right?
Yes.
This is the same thing as the earlier thing,
Yeah.
divided by x minus 1 whole square. Okay, so then you can divide numerator and denominator by we should not have taken this common. 1 second, we should have taken x power x common from these two is correct, and then taken p common simply. No, it would have been x minus. You don't have to do this complicated thing. You can just simply do x common from first and third term, and that becomes x power p minus 1
Minus 1.
minus p common, right?
Yeah.
X
And then,
minus 1, right?
yeah.
By x minus 1 whole square. So now dividing by x minus 1 up and down, you will get x into x power p minus 1 by x minus 1 minus p by x minus 1, right?
Yeah.
Okay. So the top part, we know the factorization of this, right?
Yes.
So x power p minus 1 by x minus 1 should be equal to x power p minus 1 plus x power p minus 2 into 1 power 1 and so on, right?
Yeah.
Till plus 1 power p minus 1, right?
Yeah.
So that is just simply x power p minus 1 plus x power p minus 2, so on till x plus 1, right?
Yeah.
And multiply that by x, so you get basically on top you get x plus x squared till x power p minus p, right? By x minus 1, right?
Yeah.
Makes sense.
Yes.
Then now notice that how many terms are there which have x powers in the numerator? X powers are rising from 1 to p, right?
Yes.
So there are p terms like that, no?
Yeah.
So we can split the p into 1, 1, 1, 1 like that, so that we have x minus 1 plus x square minus 1 plus x cube minus 1 plus so on till x power p minus 1, right?
Yeah.
By x minus 1.
Yeah.
Now each of them can be split separately as fractions. It becomes 1 plus x square minus 1 by x minus 1 plus x cube minus 1 by x minus 1 plus so on till x power p minus 1 by x minus 1, right?
Yes.
And this limit you have to take as x tends to 1, right?
Yeah.
So notice that each of these limits you know from the previous thing, right? By
Yeah.
L'Hopital rule, you can do 2x by 1, right? So 2 will be the limit, right?
Yeah.
And here it will be 3, right?
Yeah.
And
So
here it will be p, right? So it is 1 plus 2 plus 3 till p, right?
yeah.
Which is going to be p into p plus 1 by 2, which is what we got earlier. Correct. So without L'Hopital also it is possible to do. It is a slightly trickier solution without L'Hopital, but sometimes again what will happen is it will be difficult to do the question by L'Hopital because they will intentionally create functions which is hard to differentiate. Okay.
Okay.
So you need to be aware of, you need to be okay with simplifying and all and figuring it out on your own. Okay. Then let's do limit of x tends to 1 4 minus root 15x plus 1 by 2 minus root 3x plus 1. Don't do L'Hospitals. L'Hospitals is obvious, we can do it, right? Without that, you should try to find it. Hello? Okay, my internet was, there's a slight problem. Once again, I'll write the question again. Limit of x tends to 1, 4 minus root of 15x plus 1 by 2 minus root of 3x plus 1, right? So right now you can see that it is 0 by 0, right?
Yes.
So L'Hopital is a possible way to do it. However, what have you learned? Like you must have seen examples like this earlier, right? Without L'Hopital, how can we do this?
There was multiplying by its conjugate.
So rationalizing, right? So
Yeah.
let's rationalize the denominator and let's also rationalize the numerator because we don't want these irrational things. So let's rationalize the numerator also. Okay. This multiplication doesn't change anything, right?
Yeah.
So this becomes limit of x tends to 1, and let's multiply this one with this one, and it becomes 16 minus 15x plus 1, right?
Yes.
You have to multiply that by 2 plus root 3x plus 1 as well. And the denominator becomes this, and this becomes 4 minus 3x plus 1. And you have to multiply that by 4 plus root 15x plus 1, right?
Yeah.
So on top becomes 15 minus 15x, and here becomes 3 minus 3x, right?
Yeah.
15 common 1 minus x, and here becomes 3 common 1 minus x, right?
Yeah. So it will
This
be
cancels, and this becomes 5. 5 times this 2 plus root 3x plus 1 by 4 plus root 15x plus 1. And now you can put the values, there is no problem here. If you put the values, it becomes 5 into 2 plus 2, 4,
4.
4 plus 4, 8. So it is 5 by 2, right?
Yep.
Correct. So whenever you get some irrationals, one normal method is to multiply by the conjugates, right?
Yes.
And if it is both the things are irrational, multiply by both their conjugates, right?
Yeah.
Then let's look at this one. If gx is equal to minus of root over 25 minus x square, find limit x tends to 1, gx minus g1 by x minus 1. So this gx minus g1 by x minus 1 is basically what? Minus of 25 minus x square minus g1 will be minus of
Plus
root
root
over 25 minus 1, no?
Yeah.
So by x minus 1. So this will become plus root 24. So root 24 minus, right,
Yeah.
by x minus 1. So just rationalize that. Correct. So that top part will become 24 minus 25 minus x square by x minus 1, and denominator is simply root 24 plus root 25 minus x square, right?
Yeah.
So the top part becomes x square minus 1, and this cancels this x minus 1, becomes x plus 1, right? By root
Yeah.
24 plus root 25 minus x square. And now you can put x is equal to 1 here. Becomes 2 by this root 24 plus root 24. So 2 root 24. So 1 by root 24, right?
Yeah.
Correct.
Yeah.
So this is fairly simple, this type of question. Let's look at another type. Limit of x tends to infinity, x square plus x plus 1 by 3x square minus x plus 5. X tends to infinity means x becomes really large.
Yeah.
So whenever you have that, when x tends to infinity, it is not easy to do calculations, like doesn't make any sense to do things like this, right? So but what makes sense is knowing that 1 by infinity is 0,
Yeah.
or any constant by infinity will be 0, right?
Yeah.
So one common strategy here is to divide by the degree of the highest power, right? So if I divide numerator and denominator by x square, what I'll get is 1 plus 1 by x plus 1 by x square by 3 minus 1 by x plus 5 by x square, right?
Yeah. The answer is 1/3 then.
So the answer is 1 by 3, because now you can put infinity and it makes sense that this is going 0, 0, 0, right?
Yeah.
So whenever you have rational fractions, when we are rational polynomial, right? On top there is a polynomial and the denominator also is a polynomial, right?
Yeah.
And if x tends to infinity is a question, then to find the limit, try to get the numerator and denominator and try to divide the both of them by the highest power of x, right? Because what that will do is convert the top part into a 1 by x and stuff like that, terms like that, right?
Yeah.
In case the degree of the numerator is same as the denominator, right, then the answer will be simply the ratio of the coefficients of the highest powers, right? Correct.
Right.
However, if the degree of the numerator was less than the degree of the denominator, right, let's say you divided by x square, correct?
Yeah.
Then you would have gotten 1 by x minus 1 by x square by 1 plus 1 by x plus 1 by x square, right?
Yes.
So you would have gotten on top 0, no, then?
Yeah.
Denominator 1. So answer will be 0 in that case, because clearly you can understand that if x is becoming infinity, the denominator rises very fast, right?
Yeah.
The denominator is a quadratic, so it should rise up faster than the numerator, right? And the numerator is a linear function, so it will not be as high, right?
Yes.
So the limit should become 0 if the degree of the numerator is less than the degree of the denominator, right?
Yeah, got
On
it.
the other hand, if it is degree is greater on top, then the limit will be infinity, right?
Yeah.
So that is a straightforward application. You can try questions like this. Limit of x tends to infinity of x cube by 1 by x square plus 1 minus ax plus b is equal to 2. Okay, then find a and b. Now, on first glance, it looks like this is going to be infinity, no?
Yeah.
But obviously that should not, how is it going to be finite then, right?
Yeah.
So obviously that means that when you do the simplification of this, the numerator x cube should cancel out, right?
Yeah.
If the numerator degree turns out to be 3, no, the answer has to be infinite, right?
Yes.
So if the numerator degree is 2, however, then you can get the ratio and it will be a finite limit, right? Because denominator degree is 2.
2. Yeah.
So just simplify this and we'll get ax cube minus ax plus bx square plus b, right? Oh wait,
Yeah.
minus bx square minus b, and this side is x cube plus 1, right? So
Right.
clearly this and this should cancel out. 1 minus ax cube should be 0, right?
Yes.
Minus bx square minus ax plus 1 minus b by x. This is my whole thing, and the limit can never be 2 if I have a cube term. So a must be 1, and if a is 1, then this term goes away, and this is my final question, right?
Yeah. So
So
B should minus.
minus b by 1 should be 2, right?
Yeah.
Ratio of the terms, degrees of the highest terms, right?
Yeah.
That b should be minus 2, then only you will get the limit 2, right?
Right.
So this is an application of the same principle that we are learning. We will stop here, but what we will do in the next class is the forms of this type of forms. These are the more difficult ones. Okay, 1 power infinity forms. Also, we'll do the squeeze principle or sandwich theorem.
Oh, okay.
These things have been done in your class.
Yeah.
Okay, so we will discuss those. Just revise your limits and all, and practice questions from your book. There will be many, right, that you might or not have finished, correct?
Yeah.
So just practice questions, see what is there, and we'll continue from here. Okay. Okay.
Thank you.
Bye.
Bye.